Hi, I'm Hugh Breslin with Microchip's FPGA business unit. In this video, we're going to have a look at the factory MSS configuration for the Icicle kit. First, we'll have a look at where to find the MSS configuration file in the reference design repository. Then, we'll have a look at opening an MSS configuration and how to look at the default settings and how to generate a configuration. And finally, we'll have a look at how to import an MSS component into a Libro design. The Icicle Kit reference design can be found on the PolarFire SoC GitHub. In this repository, there's a script support folder, and this contains two .config files. In the downloaded repository, once you've extracted it, you can open either of these files using the MSS configurator to view the MSS configuration for them. To open up an existing MSS configuration, launch the MSS configurator by searching for PolarFire SoC MSS configurator in Start on Windows, for example. Then select Project, Open, and navigate to the config file that you're going to look at. So for example, in my case in the reference design, I'm in the script support folder and I'm going to open up the Icicle eMMC config file. The first thing you configure for any MSS configuration is the clocks. So in our case, our MSS reference clock input is set to be the dedicated I/O from Bank 5 ref clock, and our CPU PLL frequency is set to 600 MHz. Then we set our core clock dividers, and our CPU core is set to divide by 1, our AXI divider divides by 2, and our AHB APB divider divides by 4. Because we've got the Mac enabled in this design, we set our SGMI reference clock input source to be dedicated from Bank 5, along with our Mac TSU. And then as well, we've DDR enabled in this design, so we set our DDR reference clock input source to be the dedicated I/O from Bank 5. And then finally, we set the frequency for the dedicated I/O Bank 5 ref clock to be 125 MHz. Next, you configure your FIX, or Fabric Interface Controllers. In the case of the reference design, we have FIC0 enabled as an AXI4 slave. We have FIC1 enabled as an AXI4 master, and we have FIC2 enabled or disabled for this design. We have FIC3 enabled as an APB master to the fabric. Next, we set up our I/O configuration. So I'm looking at the eMMC configuration, and I can see that the eMMC is enabled here. The eMMC pins are enabled on MSS I/O's Bank 4, and the data 4 to 7 pins are enabled on MSS I/O's Bank 4. And this table here shows you all of the available MSS I/Os for this part. And if we have a look at the Icicle Kit Schematics, which are available on the product page, on page 13, you can see Bank 2 and Bank 4 listed off. So I can see that I can select between my SD card write protect pin and my eMMC reset N pin, and so on for all of the Bank 4 MSS I/Os. And then for Bank 2, there are several dedicated pins going out for different things like CAN and USB. Now, to select between SD card and eMMC, we need to go to the page for our eMMC interface, or our SDIO interface. There's a truth table shown here that allows you to pick between an SD card and an eMMC configuration. There are 3 input pins. If the enable is tied high, then none of our outputs are connected. If our enable is tied low, and input 1 and input 2 are tied low, we're connected to the NC configuration. If our enable is low and our inputs are high, we're connected to the NO configuration. Now the NC configuration connects eMMC. So if we have a look over here, we have our SD, or we have our eMMC and our SD pins shown on the right hand side. Our eMMC pins are connected up to the eMMC controller and the SD pins to the SD controller. And then we have our MSS IOs input pins on the left hand side. These pins are what's set during the MSS configuration in Libro, and then the input pins shown here on the right hand side actually control the configuration. So as I've the eMMC enabled in my PolarFire SoC MSS configuration on bank 2 IOs as shown here, I need to set the enable low and the 2 input pins high, which is the SDIO SW EN pin and the SDIO SW select 1 and select 0 pins. When I do that, the eMMC path will be selected. If I tie these 2 select pins high, the SD path will be selected, and I should enable the SD card for my MSS IOs. So now if we go back to the configurator, we have our eMMC pins enabled on bank 4, you can see that on the right. We also have our USB pins enabled on MSS IOs bank 2, and we can see them here. SD and SDIO are unused in this configuration, and if you want to see the MSS configuration for SD, you can have a look at the SD configuration in the script support folder. We have our Gigabit Ethernet MAC enabled, where MAC 0 is enabled on SGMII IOs bank 5, and we have the TSU enabled as well. We also have MAC 1 enabled on SGMIOs bank 5, and the management is set for MSS IOs bank 2B, and the TSU is enabled in increment mode. The QSPI is enabled on the fabric, and SPI 0 is also enabled on the fabric. SPI 1 is connected to MSS IOs bank 2B. MMUART 0 is enabled on the fabric in asynchronous mode, along with UART 1, UART 2, and UART 3. UART 4 is marked as unused. I2C0 is marked as unused, and I2C1 is connected up to MSS IOs bank 2B. CAN 0 and CAN 1 are both marked as unused, and GPIO 0 and GPIO 1 are both marked as unused, while GPIO 2, which is the fabric GPIOs, have some enabled. So for example, GPIO 2 bits 16 to 19 are enabled as outputs, along with bits 26 and 27 as outputs, and bits 30 and 31 as inputs. The next thing that can be configured for the MSS is the IO ref clock, and the default settings are used here, with bank 5 voltage set to 3.3 volts, and so on. You can also configure the bank 2 and bank 4 reference voltages, and in this case VDDI equals 3.3 volts, and VDD aux equals 3.3 volts. And next, you can configure your DDR memory. When you select a DDR memory type of LPDDR4, the default settings for the Icicle kit are automatically applied. And they're shown here, for example, the TQ width of 32, memory format of component, row address width of 16, and clock frequency of 800. You can configure the rest of the DDR settings, such as DDR controller, DDR memory initialization, and DDR memory timing, further if you want, but these are the defaults that have been tested on the Icicle kits. And finally, there's a Miscellaneous tab that you can set up to enable things like the ultrasoc debug block, JTAG trace and debug ports on the fabric, and the only one that's enabled in the Icicle kit reference configuration is the expose interrupt ports to fabric. To generate the XML and MSS component for this configuration, click the generate icon up in the top left. And then if I go back into the Icicle Kit reference design folder, I'll make a folder called My MSS. And if I select that now, the MSS Libro component and XML files for this configuration will be generated for me. If I go into that folder now, I have an Icicle MSS.config file, which is the config file for this setup. I have an Icicle MSS.cxe file, which can be imported into Libro. I have an Icicle MSS _MSS config.xml file, which is XML that I can use in the bare metal application development flow and in the HSS to actually configure the MSS on system startup. And then I have an Icicle MSS report.html file, which is a summary of what's in this MSS configuration. Now let's have a look at importing an MSS component into Libro. So let's say we've configured an MSS component, and I've called mine mymss.cfg, and we've clicked Generate. Generate the component files into a folder that you want to, so I've created mine in a folder called mymss. Once that's complete, you can go to Libro. So in my case, I've created an MSS test project, and I've created a smart design called MSS Base. If you go to the design flow, up at the top left, there's an Import MSS option. If you double click this and browse to the folder where you generated your MSS file, you can see an MSS.cxe file that's been generated there. And if you open this, the MSS is going to get imported into your Libro project. And you can see it in the design hierarchy. I now have an MSS component called Icicle MSS. And I can drag that onto my design canvas. Any of the pins shown in black on the left or right of the component are fabric pins. Any pins shown in red that are already promoted to the top level are MSS IOs, and any gold interfaces, starting with the name FIC, are the fabric interfaces for the MSS. So on the left, we have the FIC0 AXI4 slave from the default configuration, and on the right, we have the FIC1 AXI master and FIC3 APB master from this configuration.